Yeah, g'day Paul, it's Charlie. Hey, firstly, thank you very much for providing that information this morning. I certainly found that very useful just to go back over the circuit and to double check what I had done. Right, so in the end, I didn't have to change the op amp that's acting as the comparator. So comparing that triangle wave with the audio coming in. That was fine, and I could get a nice full range there of duty cycles coming out of that, which was good. And then that fed through the MOS driver and then through to the MOSFET. So what you're seeing there on the top is the drain of that switching MOSFET. So I'm pretty well driving it through as far as I want to go. I can crank another couple of 100 millivolts drive into there just to get it to go to the very ends. But then of course the triggering gets all mucked up. So let me just drop that back down another couple of hundred just so we can see it. And that's sitting on around 700 Hertz. So we get an idea of get to see it sort of moving backwards and forwards. And down there of course is the light bulb, which is acting as the load on that particular MOSFET. Right, so what I'm going to do now is I'm going to disconnect that light bulb, and I'm going to connect in the low pass filter and connect the light bulb to the output of that particular filter. So a couple of things going on here. If we just concentrate on the bottom, let me just zero that, so that second line there is going to be 0 volts. And if I was just to crank that modulation down to 0, as expected, 5 volts per division, we're about 5 volts up. It's a VCC here of 12 volts, and then as we introduce the modulation, we get that varying nicely. As we approach 2 volts, we can see that sort of varying quite nicely, not all the way down to 0 and certainly not up to twice, but certainly a lot more in terms of what we were getting before. What I have found interesting is that artifact there, that little peak there. If I was to crank up the drive a little bit more, that starts to cause some kind of well, that's the DC coming out. That bottom line there is the DC coming out of the filter, and we get some kind of artifact coming through there. So that may be as a result of the type of diode I'm using. Now, what did I say it was yesterday? It is it's an MAQ00352, so it's supposed to be a fast switching diode used for rectification purposes, and if I recall, I do remember seeing that particular diode being mentioned on one of the websites somewhere in one of the designs. But I'll be curious to know what diode you use, and I might try and source that one. At the moment, I think you can see down there, there's only one MOSFET and one diode at the moment. So if I was now just to crank down that drive just a couple of 100 millivolts, we get back into a linear region there. So I guess, well, not I guess, it would appear that the reason why the circuit was not working correctly yesterday was because I was not presenting the correct load or the correct terminating resistance on that filter down here. I was using this little Class A amplifier over here as a test power amplifier, and it would appear, I don't want to say clearly because I don't know for sure, but it would appear that the resistance of that circuit was too high, which was upsetting that and causing grief. But now, not now of course, but the observation now by applying that 2.7 ohm load here, that it's making things work a heck of a lot better. So that's good. So if I look at that, apart from that artifact there causing a bit of grief at getting near 100% modulation, it would appear to be working reasonably well. So yeah, so that's where I'm at. Like I said, I'd be curious to know what diode you're using, and hopefully I'll do a little bit more googling around and see if I can work out how to get rid of that or make that a little bit better, if indeed it can get rid of. For interest's sake, if I was to disconnect that diode, so it's now been disconnected, it does change the waveform subtly. You can see that's now in circuit out of circuit. So it's changing that leading edge there a little bit. And if I was to go up, say another 50 millivolts, I get to a point where I'm just starting to get the interference coming through there. You can just see it sort of blinking. If I now put it in circuit, it cleans it up. So it's definitely knocking something back a little bit, but I don't think it's enough to really drive this thing up to 100%. Assuming that if I was to crank this up a little bit more, and I start to get really near 100%, my assumption is that that rubbish that's coming through the filter is not desirable, because there must be, to get that, there must be some other AC components in there which is going to give me grief in the power amplifier. So to keep all things nice and linear, my assumption is it needs to be nice and clean like that. Anyway, there you have it. So that's, well, it's interesting. It's good news that I don't have to redesign anything at this stage. But just like I say, just curious to see what your thoughts are on that. And in parallel with that, I'll do some more research tonight and see what I can find out. Okay, cheers, Paul. And like I say, thank you very much. And I really don't want to hassle you, but you did say you were interested. So here goes an update, and we'll continue going from here. Cheers.